let's start. So thank you everybody to join us for today's webinar about GraphBit launching soon, our very efficient enterprise-grade Agentic AI framework. Sorry. With me today are Musa, Molla, our CEO. We have with us today Rahmat, Ullah, our head of AI labs, and we have Yeahia, Sarker here with us, our AI engineer that worked mostly what we see today. Let's go a short view on the agenda, what we want to talk today about. One is about the vision and about GraphBit, what is agentic AI and why frameworks are critical. We will also talk about what we are built with agentic AI, around agentic AI with GraphBit, and also about some pain points and how we solve them. And we will also get a short demo walkthrough. And in the end, we will also have some time for our question and answers. And now I would like to hand over to Musa to give us a more bigger picture about GraphBit and why we are developed that framework.
Thank you, Sebastian. So first of all, a warm welcome and thank you for joining the call today or the webinar today. So let me explain in short why we have developed GraphBit. I think we all know that agentic AI market, this is growing very rapidly. And if you look at the LLMs, they are improving at an incredible pace. If you see that, okay, there is almost in every week or every month, there is a new model coming, which is surpassing all the existing models in every known benchmark. Yet, despite all this progress, if you look at the statistics, the vast majority of the AI projects are failing. So we ask ourselves, so what are the gaps? Why these AI projects are failing, although the LLMs are advancing so fast? Actually, we have experienced it firsthand. So let me share it with you. So over the past year, we have developed a lot of AI solutions with some of the largest corporations in Germany. And like everyone else, we started with the existing open source LLM frameworks. And to be frank and very fair with you, they worked pretty good during the POC and MVP phases. But as soon as we moved those solutions in the production under real stress, everything changed. Agents would break apart halfway through. They will lose context in communication. There will be a leakage of memories. And the worst part of them is that debugging was the absolute nightmare. So we obviously needed to fix it and re-engineer those LLM frameworks. And we did so much changes that at the end of the day, we could not recognize the LLM frameworks anymore. And even then, we could not really optimize the frameworks the way we wanted. So what are the reasons behind it? Because most of these frameworks, they are really never built for agentic solutions. They use completely wrong technology stacks, and it makes it almost impossible to achieve true reliability and scalability. And we found this is one of the single biggest bottleneck why these agentic AI projects are failing, because of these shortcomings of the LLM frameworks. And therefore, we knew instantly we need to do a better job. And exactly that's why we have built GraphBit. This is our proprietary patent-pending LLM framework designed from the ground up for the efficiency, scalability, and reliability. So just to give you a little bit of idea, GraphBit is developed in Rust for speed and safety. It has a Python wrapper for the developer's edge. We have built-in atomic reference counter for scalability. We have also incorporated serialization, deserialization for scalability. And we have a fantastic documentation for the developers. And the result is, of course, astonishing. So GraphBit runs several times faster. It's far more reliable and scalable than any other LLM frameworks that you have used. And finally, it makes the complex agentic solutions a reality. So this is not simply an incremental step or a little improvement of the existing frameworks. This is a complete rethinking how agentic frameworks should work. And we are really thrilled to demonstrate that to you today. Thank you, Sebastian.
Thank you very much. I have two questions for you. What is agentic AI and why are frameworks critical?
Thanks a lot. So I think when it comes to agent or agentic framework, there are so many different definitions. So let me try to put it in a very simple way. So for me, an agent is a digital actor that is trained to do a very specific task using the capabilities of LLM. One of the main characteristics of the agents are they should be able to communicate with each other and share context to achieve a complex goal together. So that's what agent is. Now, what is the framework? So the framework is the orchestration layer, the system that manages these agents and connects them really reliably to the LLMs. Now, you may ask, with LLMs getting smarter every month, are these frameworks going to be relevant in the future? I think this is a very good question. And the answer is absolutely yes. In fact, they will become more critical than ever. Let me explain why. So LLMs are black boxes. Nobody, even the people who really created it, really knows how exactly they behave. Nobody figured it out, and there is no way they will figure it out. No serious organization can really afford to just dump critical processes into a black box without oversight. They need auditing, they need transparency, they need the ability to trace every step, especially when things go wrong. That's why frameworks are the only real defense layer against this unpredictability of the super intelligence system that we will have. Therefore, for any serious organization, the importance of LLM frameworks will only increase because this is the only defense layer they have against a black box. So that's a short introduction regarding what is agent, what are the LLM frameworks, and why we will need it. So thanks a lot, Sebastian. That's from my side.
Thank you for the explanation. Very good answers to the questions. So now let's talk about GraphBit. How do we build agentic AI with GraphBit? I would hand over to Yeahia, our engineer, to give a deeper insight of GraphBit.
Thank you. Thanks, Sebastian and Musa. It was a really great intro. And, we faced really critical issues, as just mentioned. And also, I have been developing AI solutions for years, and I have faced a lot of problems, especially in rack systems. But the traditional LLM frameworks were slightly able to handle that. But when it comes to agents, they were not that much good at it. What it happened that when we tried to build solutions, they were not actually meant for agents. They were meant for RAG orchestration. And also the problem with performance, safety measures, and the scalability issues. So we were discussing what to do, and then we found out that okay, we should pick up something compiled language, Rust, that would help us to get system level performance. And with the Python binding, we have managed to give it to everyone so that every developers in the community can use, because most of the agents are built on top of Python. So we try to make it better so that it works. And also as just mentioned, that it is patent pending. So we have built something special that is unique in terms of unicity. So I'll just go into a bit technical on how we did it. So at first we did is that we implemented 3-tier architecture when the core engine, the workflow engine, is written in Rust, and we have attached it with the Python library, which is PyO3. So what happened is that this combination has lower memory footprint compared to other mainstream Python frameworks, and it handled all the agent orchestrations, graph executions, and the LLM provider management. So we have specially built this GraphBit on directed acyclic graph structure that actually makes the workflow representations. So the workflow graph implements dependency over batch executions and topological sorting and for optimal node ordering. And also it has cache adjacency information for performance. And that's how we achieved a really good, effective engine performance. And also, like everyone knows that there is a reliability issues with the agentic framework. So we try to make sure that it really goes with the proper serialization and deserialization process. What happens is that we are taking counts at every reference that we are making, and we are taking the types that it is following the proper types. So even when we are having API failures or any kinds of failures due to internal issues or external issues, we can immediately roll back, or we can immediately put in agents that can take care of it, so that was really exciting. And the most important part, which I would say, is that we have make it enterprise grade. That is, it has the circuit breaker pattern mechanism, which actually is configurable. So you can configure the timeout, you can configure the state management. So it has a built-in state management, like React.js has Redux, so it has that. And also, like, the implementation tracks failure counts within the time window and provides exponential backup for recovery attempts. So this actually makes it more efficient at scale. So this was really helpful. And not only limited to that, we have a really good error handling capacity. So if you enable the debug options in our framework, that will help you to trace back what actually happened when it broke, so that you can fix that part and you can run it very smoothly. As also I mentioned, that it can also be handled automatically, but what if you cannot handle it automatically? So then you can also handle it manually. So the error propagation is handled gracefully with context preservation, and the system can continue the execution of independent workflow branches even when some nodes fail. So I think that is what makes us unique than others. And also, like, I'll definitely go a bit more technical, but that is what is our core thing in our GraphBit structures. So also we are publishing the we have make it patented, as just mentioned, but we are also have a comprehensive documentation for Python developers that will help to use them without learning any Rust programming language. So you can just use your regular programming languages and then Python, and then you can use it. That's it. So that's it, Sebastian, from my side. Thank you so much.
Thank you, Yeahia. So it's an interesting insight about that and how we did Agentic AI within GraphBit. But what are the today's pain points and developers are facing? So I would hand over to Rahmat to talk about more about what are the challenges, what are the pain points of today's developing of AI solutions. So Rahmat, up to you.
Yeah. Hi, thank you. So first, let me show you a picture of what developers are actually dealing with today. So you can see that there are two sides. Like, let's say we have built a elegant agent workflow. Like, let's say we build it in Friday, and it works perfectly in development. And when we try to actually show it in Monday morning, and then the production load hits, and suddenly, let's say your AI framework pipeline is consuming more CPU than you expected in production. And then for a simple task, your orchestration that handles 10 concurrent requests, now it's dropped connection at 50. So this is a familiar case for all of the developers who actually built agentic system and agentic workflow, right? So we didn't just guess at those problems. We ran over 600 benchmark tests across 5 frameworks, 5 different cloud environments, and testing everything from simple tasks to complex multi-agent orchestrations. And what we found out was very concerning. And that is instability in under load. So there we actually, when we actually test in multiple frameworks, we didn't find any of the solutions that provide us the 100% stability. In our testing, we see the complete failure when the frameworks hits their limits. Imagine like you are explaining to your CTO, like when your AI agents stop responding, like during a peak hours. So even like sustainable framework struggles. And in QAI, for instance, like in at peaks, it actually consumed like 13.6% like CPU uses for a parallel task. What we saw in our test, that's nearly 40 times higher than what's actually necessary. On an AWS T3 small instance, that's the difference between handling 100 users and like 400 users on the same infrastructures. And there is the memory nightmare. You may also face these things as well. In some frameworks, like consume excessive memories for basic tasks, but there are some real problems. When agent lose context in mid task, they don't just fail; they fail silently. We observe framework dropping context token entirely in our complex workflow test, and some frameworks recorded minimal token processing. And despite running for like 40 to 50 seconds, like your agent thinks it's working. Like your logs also shows that, okay, it's active, but nothing is actually happening. Like it will be a debugging nightmare. We face these things as well. And there comes the security as well, the most important things. That in most framework that handle credential through environment variable and scattered across your code base. And like API keys in plain text configuration, no built-in secret rotations, and no credential isolations between agents. So one compromised agent means all of your API keys are exposed. Like we found that 4 out of 5 frameworks we tested have no native secure credential management. You are essentially running production AI system with just the security of 2010 web application. So there comes the next one, the performance. So we run parallel pipeline testing. So there we saw that in QAI, it takes more than 50 seconds on an M1 Mac PC. For context, the same task should take not more than 10 to 15 seconds. That's more than 40 seconds of pure waste. And if you say for at scale, it's 10,000 requests. If you say that you are processing 10,000 requests per day, then you are losing more than 100 hours of computing time in every single day. And there are some other nightmares as well. Like for the CPU efficiency, LangChain in our test in LangChain averages 3 to 5% CPU, even for a simple task. So if you multiply those across your Kubernetes cluster, and you're literally burning money on your idle cycles. So there are no true concurrency and parallelism as well. In our concurrent task, we saw just 10 simultaneous operations, execution time, it's over 65 seconds. So can you imagine you have to wait for 65 seconds for just one execution? Framework like QAI, and we run it on Intel systems. But that's not even the worst part. The framework achieves concurrency through threading tricks, not through parallel execution. No process isolations, no fault tolerance, no agent, only the agent caches, and they all go down. And you can see in in Python GIL limitations, but every developers and every agents, every developers that they're building agents, they know the limitation of Python GIL limitations, but most framework just accept it. They don't even try to work around it. So here's where we come. Frameworks that crash under load, leak memory and services, and can handle basic security with CPU cycles and fake their concurrency. This isn't sustainable. As Yeahia will show you next, there are a fundamentally different approach, one that actually solves those all problems instead of patching around them. So yeah, hand it over to Sebastian. Yeah.
Thank you very much. And I guess that's one of the challenges also the audience are facing. And now let's talk about how we solve them. So over to Yeahia, how we perform and solve that pain points with GraphBit. So Yeahia.
Thank you so much, Sebastian. I think Rahmatullah has mentioned some of the existing frameworks issue, and these are the real pain points, if I be honest with you. So we have seen the memory issues, we have seen the CPU issues, we have seen that, okay, we cannot build an agent properly, okay, we cannot orchestrate it in a production environment, we cannot use different kinds of LLM providers for different nodes or different agents, we cannot have a planning agents properly. So we try to solve all these issues. Now, in terms of memory, first if I speak about the memory, so what we did is that we used a custom Tokyo runtime with an optimized thread pooling. So it has a 2x CPU per core capped at 32, so that the reduced stake size is 1 megabyte per thread. And we have our own blocking thread management system that uses a registration and block technique, so that you can also run concurrent agents even with the Python GIL problem. And also like the runtime uses 𝐤𝐴𝐺 as the global allocator for Linux-based systems. And it really helps on Linux-based systems for memory management and the fragmentation reduction. And you might be wondering, okay, so like you have been connected the Rust engine with the Python, so there might be some kind of abstraction layer issues. Probably you are using too many abstraction layers like other frameworks. No, we have zero copy management system. That means that we do not have any operations that goes back and forth. So the PyO3 binding minimizes the data copying between the Rust and Python through the reference and borrowed data. And also like the serialization and deserialization is optimized with the JSON array with streaming where possible. And the system actually avoids unnecessary string allocations with the type definitions. So like as there are Indentic types in Python, so in Rust there are cow types. So this actually helps to build us a better serializations for better reliability. And if we come to the like the API failure, what just Rahmatullah has mentioned, that we have used response caching and connection pooling for HTTP clients. So that makes the continuous async connection to the APIs really structured and like really effective without much losses. And the agent registration uses like the read write blocks to allow, as I just mentioned, to allow the concurrent access for the read, for the thread safety mechanism, for specifically for the connection pooling purpose. And also like I have just noticed that people are a bit interested in how, if the different types of agent can use different types of LLM framework. Yes, it does. It actually helps. So we have supported OpenAI, Anthropic, DeepSeek, Hugging Face, Ollama, Perplexity. So you can almost use all kinds of LLM providers that can actually help to select what kind of LLM you want to use. And not only to that, we have also rate limiting and response formatting as well, so that you can get a consistent formatting when you are building things in production. So also, if I be a bit more into this, we can say that we have also a request management systems that uses a retry mechanism with a specific back off strategies, so that the system automatically fall back to alternative providers when it cannot find. So if you allow it to do. And for tool calling, we have, so the tool calling was a bit difficult because the tool calling was happening in Python and the core framework is written in Rust. So we tried to avoid any kinds of GI or log during this issue. So that's why like the system strictly enforced JSON schema for this. So you can just use the tool call. That means that you can call any third-party functions into your agents with the just simple Python decorator, you know. And also, like just I mentioned, that it really helps out, you know, with the runtime configuration validations, and it has a good execution process of the async operation, and also it has a really interesting features, which is the dependency aware batch processing. So the execution engine allows us the graphs to create optimal execution batches where all the dependencies are, you know, like validated before the node execution. So this actually maximizes the parallelization when you want to build a concurrent nodes for a single workflow agent. And I think this actually helps building a scalable production system. So thank you so much, Sebastian. It was good actually talking about this. Yeah.
Thank you very much, Yeahia. And as you explained, we built it up from the ground, and we think it's very innovative how we did it, and that's also the reason why we patented it. And now over to Musa to give us some feedback about or some insights about their patent filling stuff.
Okay, thanks a lot, Sebastian. I think as Rahmatullah and also Yeahia already explained, you know, GraphBit is a significant improvement of the existing solution. It's not necessarily just an improvement. I think it's a complete redesign. So as they explained, we actually solved the fundamental shortcomings of the existing frameworks with our sophisticated algorithm and these modern technologies that we have. And the result is really exponential leap in efficiency, reliability, and scalability. So we have seen it, and once we did the benchmark, we are very excited. And of course, innovation of this magnitude must be protected. That is exactly why we have applied for patent both in USA and EU to safeguard our technology. So therefore, GraphBit is not just unique, it's also patent protected. Thank you, Sebastian.
Thank you very much for the short explanation. Now let's move over to have a bigger or deeper insight about the architecture and also get some demo from Yeahia. So Yeahia, give us an overview about the architecture and why we used this technology.
Yeah, like I think that is really a good part that you know, like we have a agent creation mechanism that allows to build workflows very easily. So with the Rust Foundation, I think it has become much more easier to build a, you know, that has something both speed and safety. So I will just dive into the demonstration of a little project that can help you to understand what we can do with GraphBit and what are the trade-offs, if we have any, that has been done, and what are the issues that other framework has. So we tried to build a peer review framework for this. So what happens is that, let's say you have a specific project on GitHub and you want to add features on top of it, or maybe a bug fix, or maybe a documentation that you want to provide. So that is called a PR review. And this PR review is reviewed, this PR pull request get reviews by someone who knows about this project or who has been worked on this for a long time. Mostly it is done by senior engineers and sometimes engineering managers. So it is really hassle to do this review. So we tried to build a small solutions that can actually show you that how different agents can connect together and build a PR review solution for you. We have tried to build it with both LangChain and GraphBit so that you can see the difference, how these two are made, what are the reviews, and how it differentiate with GraphBit. So I won't talk much. I will just dive into this. So I will share my screen. Okay, done. So
1 second, I will give you.
Sure.
Now it's yours.
Okay, so at first, let me demonstrate you the peer review agents built by LangChain or built with LangChain. So as we can see that this peer review actually has many portions, so many agents, or you can call it sub-agents. So the first one is the quality assurance, and the second one is the security reviews, and the third one is who is really good at performance and algorithm, and the third and the fourth one is the quality assurance engineer, and the final one who checks the documentation is in process. And all of these are coordinated with who reports to the principal engineers. Okay, we have collected all the scoring, so you check whether it is good or not. So more like it's a small IT team that is actually reviewing your code that is unique. So let's just run it and see that if it actually works or not with LangChain, and how it is the result. So we're just gonna create another branch. So test LangChain. So we are gonna show it to you now. Done. So we have pushed the code, and now what we'll do, we will try to create a pull request. Okay. So as you can see that LangChain has already started reviewing it, and all of its sub agents is running. And we will now see what is the review. So as we can see that the overall assessment is this. So it is not properly structured, and like it has given 5.0 on request changes. So the code quality, functionality, and documentation and everything. The problem is that it cannot coordinate to the principal engineers or the coordinator templates properly. And as you can just see that there are not really proper mechanism to build agents. So these are basically using the LLM provider APIs to wrap the prompt in a format like agent. So these are not actually agents that are talking to each other. So LangChain does not have this support. Now we will try to see the same thing with GraphBit. And now we will also change. So for better for better transparency, we will just use the same code so that you can see that what are the results like with the GraphBit. Okay, so we have pushed the code, and now we will do the PR request. So you can see that it has started the reviewing process. Now let me scroll up a little bit. Okay, and it is reviewing. So in the backend, it is actually running those agents for you, and all of those agents are done. It has been reported to the principal engineers, and we will see this comprehensive review. So you can see that the documentation, like it is really comprehensive. So why the difference? Because LangChain uses some built-in prompts that includes the includes the cost associated with this. So you do not know how to control if you want to make something that is strictly controlled by you. So we tried to give it a elaborative result, but it did not give us an elaborative result. But when we tried to do it with the GraphBit, we saw that okay, we are getting a comprehensive review from documentation perspective, from the security perspective, from the from the senior engineers, and they are reporting to the senior engineers, and this is the next steps, and it has a good format because we do not enforce any kinds of built-in prompts. And let's just see the let's just see the agents, how it is built. So so these are all these agents. These are security reviewer, the performance reviewer, and the testing reviewer as well, and the documentation, so and the reviewer that works. So we'll just go where it is called. Okay, let me just go to where it is called. And yeah, so in LangChain the process is linear, but when it comes to GraphBit, it is a non-linear. You can also build non-linear multi-step agents, or a system that has many sub-agents connected in a non-linear way. So you can see that all of this section is connected to the coordinator, who is the principal engineers in terms of code review. So it really works better than other frameworks. It is quite easy to do, and you don't need to be put so much hassle. And now what you want to do this by yourself, so we have a really good documentation. You can just go to docs.graphbit.ai and you will see the documentation by yourself. It really works out of the box, and so much easier to read. And now we have really talked a lot about performance. So what are the performance? Let's just go to the slide over a bit. So for this particular experiment, we have conducted this small experiment to check what is the CPU and memory for both LangChain and GraphBit. So we can see that GraphBit does not take constant CPU. When the agent is running, it goes to 6 and 7%. When the agent is not running, it goes close to 1%. But in terms of LangChain, it is taking constant CPU of 20%. So just imagine that you are running, they are not even properly running the agents. So what will happen when you build so much agents around it? And the scalability issue, you can just imagine by yourself. And also see the memory, it is almost like doubled. So you can see with this small experiment that it has scalability issues and how much efficient is our framework. So thank you so much, Sebastian, for letting me show this. And please, let's go to the next section. Yeah.
Thank you very much for the demo. And as you explained, it is not just about the results, it's also about the performance. Of course, the results are the most important part, but benchmarking as well. And there are some more frameworks out in the market. So let's jump over to Rahmat to give us a more overview about what's also beside of LangChain on the market and how the benchmark are looking with these competitors.
Thank you, Sebastian. So, number don't lie. So, let me show you exactly how GraphBit actually compares to the other frameworks you are probably using today. So, what you are actually seeing here is not just some cherry picked. Those are average result from 10 runs per scenarios, like tested across like Intel Xeon and AMD EPYC, and also Windows and Apple M1 systems in real hardware. And let's first check the CPU uses. So here you can see the results of the CPU uses. So when we run a simple task, for the simple task execution, we get the lowest CPU uses in our GraphBit. So in our GraphBit, the CPU for a simple task, it takes only like 0.35%, and for the other frameworks, it takes like more than like 4% of CPUs. And also for the 𝐸-AI, you can see it's like it's taking more than 30% of the CPUs. So those are some kind of nightmare, you can say, in terms of the uses of CPUs. So in Pydantic, it's like 11 times higher, and in LangChain, it's like almost 15% higher. And 𝐸-AI, it's like 38% higher uses than GraphBit. So this isn't just a typo. Like GraphBit is literally like you can say like 15% higher than like 15% like better than 15 times better than LangChain, and also like 38 times better than like 𝐸-AI. It's, and also like if you consider like let's say we take a comparison between like 𝐸-AI and like GraphBit, then you can see in like if you want to execute a task, and for that one you need like let's say a 0.1 core for GraphBit, and with the same task you will require actually be at least 4.3 cores for the same work. So you are seeing the difference, right? And also for the memory, so you can see the memory as well. So what it tells you, you can see in GraphBit it actually only takes 0.038 megabytes for like memory intensive tasks. And when it comes to LangChain and Pydantic AI, they takes almost double. And 𝐸-AI, they are just out of the league. So like think about that. Like for every GraphBit agent, you are using only 0.038 megabyte. And when it comes to like 𝐸-AI and other frameworks, you are using higher rate of memories. So, and it's not actually bound to the memories. You can also see the throughputs as well. So when it comes to like the throughputs, with the same with the like optimized or like you with less CPUs and less memory, you will get better throughputs as well. So you can see here, like for GraphBit, you will get 77 throughputs in just you can say like in per minutes with same infrastructures. And then for the higher infrastructure, it will give you for the LangChain like 73 throughput per minutes, and Pydantic is closed, and also like 𝐸-AI is at least 20% lower. So GraphBit matches and beats everyone on throughputs while using a fraction of like resources. It's not a trade-off. You can say it's better on both axes, in infrastructure and also in throughputs. And then you can also see the metrics for infrastructure uses as well. So in the infrastructure, we tested it on like AWS T3 large instance. And if you run a T3 large instance like 24/7, and then like let's say you are running 10,000 instance, or like you want to like execute 10 million requests per day, then what it looks like for your like infrastructure. Let's say if like other frameworks like cost you like 10,000 instance, then for the same like performance and so for the same outputs, GraphBit will only need 600 instance. So if you just try to figure out the prices, then you'll see the price has a larger like difference as well. For each cases, like let's say for the annual cost of other frameworks that execute same amount of requests actually takes more than 500,000. And when it comes to GraphBit, it's less. You can say like for the annual cost, it's like only cost more than 7 million. When it comes to GraphBit, it's like less than $500,000. So you are saving more than 6 million for per services. So let's say if you consider yourself in 5 or 10 years, you will be a tech giants or something like that, then you will save with the GraphBit, you will save billions of dollars. So this is just a fact about the cost. There are also other things as well, like you can say for the security, we already explained that what we actually solve, the security, the concurrency, and the failure rate, we already reduce everything. And the security, you will get the top-notch security here compared to other frameworks. So those aren't some kind of incremental improvement. This is a fundamental leap in efficiency, like 35x lower CPU, like 10x lighter memory. So these numbers actually don't tell any lies. And also you will get 100% stability in any kinds of loads. And those benchmark will be published, and also the code will be open, and you will be able to reproduce every single number I have just shown you today. So yeah, and we will be waiting for your feedback on those benchmarks and also the uses as well. Yeah.
So thank you very much, and yeah, it's a very big number of savings per year with GraphBit, and we saw so many questions during the session. We now want to move over to the question and answer section and get some of your questions answered. We will anyhow answer all of your questions afterwards, but we have not the time today to go through all of them, so we will pick some of them. I have one question to Rahmat about, can you explain why GraphBit is so CPU and memory efficient compared to others?
So, GraphBit is lean because the hot path of a Rust core, and with a thin Python API, so orchestration works doesn't bounce through slow and reflective layers, or it uses zero copy data flow that already explained by Yeahia, and also for the allocations, and also for the lock-free queues, and for the streaming parses, and to avoid intermediate objects, plus you can say for the persisting HTTP and clients and the connection poolings. So those things actually make it very CPU intensive, CPU efficient, and also memory efficient as well.
Okay, thank you very much. I have another question from the audience to Yeahia. How easy is it for a Python developer to get started with GraphBit?
So we still didn't make the repository public, but when we'll do, you can just perform pip install GraphBit and you will be able to download the latest version of GraphBit. What is the good interesting part is that there are currently no dependencies, because the complete thing has been written in Rust. So we just download it without any dependencies and go to the talks.graphbit.ai, and you will find the documentation there, and it is really easy to code. All the documentation has been validated multiple times and has been presented to you in such an easier way so that you can just deep dive into it. So for any kinds of suggestions, we are up to it. Thank you so much, Sebastian.
Thank you for the answer. Musa, I have another question for you. What's your long-term vision? Do you see GraphBit becoming the standard for AI workflow orchestration?
A fantastic question whoever has asked. Thank you. So I think that Maruf and Rahmatullah, his nickname is Maruf, and also Yeahia, they already shown what GraphBit is capable of. You have seen that when it comes to efficiency, reliability in every metrics, GraphBit is sometimes from 5x to 38x better. Think about it. 38x better than some of the existing framework. So this is from it's almost like another planet. And of course, so this we think will fundamentally change how AI solutions are being built. Therefore, just as Kubernetes has become the global standard for cloud-native workloads, GraphBit is really designed to be the orchestration backbone for the agentic AI era. Our vision is to make AI workflows modular, make them secure, make them production ready by default. We want to have a platform that enterprises, startups, researchers, all of them can rely on. And over time, we will see that GraphBit shaping an ecosystem where agents, data, workflows, they interconnect seamlessly, and they will set the benchmark of how AI is built, scaled, and trusted worldwide. So definitely, we see that GraphBit is becoming the standard for AI workflow orchestration in the future. Thank you, Sebastian.
Thank you. I have another question to you. Why do you think the industry needs GraphBit now compared to the existing frameworks?
Thank you. I think some of it you already have covered. I think the way Maruf and Yeahia explained the current shortcomings of the LLM frameworks, and I also explained at the beginning, is that LLMs, they are advancing rapidly. This is the future. The enterprise are really investing. But when it comes to the AI solutions, you see still most of them are failing. So there is a huge gap between what LLMs are capable of and what a agentic solution that is built on top of AI LLM is really able to deliver. And I think there is a huge gap, as I said, there's a gap when it comes to reliability, there's a gap when it comes to speed, compliance, and so on. And therefore, you need to have a better technology to really utilize this LLM's capabilities and build a solution that is reliable. And therefore, we have built GraphBit. I think we already have shown that this is built on some fantastic innovation. We have GraphBit has a Rust core. It has a Python wrapper. We have advanced memory management, which has atomic reference counter. It has serialization, deserialization. We have seen that almost in every different benchmarking, this is performing 5 to 7 times better. And therefore, this will provide the platforms of the enterprises, for the developers, for the entrepreneurs to build their agentic solution that will be reliable. And therefore, GraphBit is needed, and we have built it for the people who need agentic solutions. Thank you, Sebastian.
Thank you. Thank you very much. I have one other question to Rahmat. How does GraphBit achieve higher throughput while keeping the resources usage so low?
So, for the high throughput comes from a graph scheduler that actually parallelize independent steps, for the overlaps of IO and with computes, and also batches models calls, and for applying you can say some back pressures, so workers stay structured, but memory doesn't increases, and also for the token streaming, and it's less downstream node start early and retries, and also for the timeouts, and are also budgets to cap tail latency, so that it doesn't goes to for the, let's say for the CPUs, it doesn't goes up to 99%, so that it can fail. So there is a cap as well, and also for the connection pooling with HTTP2, and also for the multiplexing and remove per call steps cost, and also caching of tools, models, and clients, and also deterministic cancellations as well. And you'll get some sustained concurrency with tiny per task overhead, and more computed tasks per seconds, and without dragging CPUs or RAMs. Yeah, that's how actually we achieve this one. Yeah, these throughputs, and while keeping the resource uses so low.
Perfect. Thank you very much. I have one last very interesting question to Yeahia. Why Rust? Why not C++? As the other frameworks are using C++. Is that the sole reason GraphBits require low memory and CPU power?
Okay, so it has a lot of good points to answer actually. So the reproducible build is really good, and the fearless concurrency of Rust over C++ is good. I know that C++ is used in building deep learning frameworks, but most of these agentic frameworks are built on top of Python. So we had to choose a language between Python and C++. So like if we look at the if you look at the stability, I know C++ is also stable, but if you want to find something that is memory safe, and also like the testing of it is much more easier with Cargo tools like Cargo, and also like the asynchronization is really good in C++, and also like there are tools for formatting and workspaces. It really makes it much more easier to build an ecosystem around Rust for our particular project. So that's why we use Rust, and also we wanted to achieve more memory related performance so that it can scale effectively. That's why like we pick Rust. Yeah.
Thank you very much. So we are almost done for today's webinar. I would give Musa the last word before we are closing. He has some more important last informations for the next steps.
Thanks a lot, Sebastian. First of all, thank you everyone for joining. Really much appreciate, and also for Sebastian, Maruf, and Yeahia really having a fantastic webinar and explain it to the audience. So just a couple of things. I mean, you have already noticed. I think with GraphBit, you really finally have a foundation to make your agentic solution successful. Not necessarily only in theory, like in POC or MVP, but really in real world production. So that's the important message that you should take with you, and that now really you have a framework that you can reliably use in the real world production under any stress. And another important topic is that we as a company, we are ISO 27001 and also �TZK certified, and therefore GraphBit is really built on this certified infrastructure. As a whole, that means that GraphBit is not just a huge leap forward regarding technology when it comes to efficiency and scalability, but also it provides the highest level of security for enterprises who trust their most critical processes and data and use the LLMs. And as with any true breakthrough, there is a huge fast mover advantages. So therefore, my invitation to you is very simple: be among the first to experience it. Register yourself for our early program that we have on our website. And also another important thing is that we are launching our product on Product Hunt on 14th of September. That means in less than 2 weeks. So we invite you to really join Product Hunt, follow our product page, and also please, upvote or follow our launching activities. With that, thank you everyone for joining again, and thank you Sebastian, Yeahia, and Maruf for the presentation. So from my side, that's it. I wish you all a fantastic rest of the evening.
Thank you very much. And now we are to the end. As explained, we will answer all your questions afterwards. We will share it. Go in contact with us, and we are on LinkedIn. Each of us connect. We will answer all your questions. And we are so excited to the launch and to the product we developed, and now waiting for your feedbacks and how you will real life testing the framework. So thank you very much for today. We are now at the end of the stream, and wish you a nice evening. Thank you.
Thank you.